Hello everyone, this is Ankit from Kailasha Foundation Fun and Learn portal. I hope you all are doing well, and this is your fourth lecture of number system. In this lecture, we are going to discuss how to find the last two digits of a number and remainders. Okay, so this lecture is intended for CAT students and SSC CGL students as well, but mainly for CAT students. Okay, so we'll be discussing problems like we'll be discussing problems like uh, find the last two digits of 26 raised to the power 81, 94 raised to the power 561, 72 raised to the power 842, etc. Okay, 47 raised to the power 900. So how will this work? That is important. Okay, and unlike the unit digit problems that we studied in the previous lecture, lecture 3 of number system, cyclicity doesn't work well in these problems. Okay, so there are certain rules, there are certain observations, there are certain shortcuts and tricks. We will learn those, and we will try to master this topic because it is a very important topic in CAT. Okay, so let us start. The first point is, for a number a raised to the power k where a ends in 0, like 240 raised to the power 113, so this ends in 0. For a number a raised to the power k where a ends in 0 and k is a natural number, we are not writing this sentence every time. It is already understood that we are discussing natural number powers. Okay, so we are not writing this every time now. So for a number a raised to the power k where a ends in 0, second one is, for a number a raised to the power k where a ends in 5, and third one, for a number of the form 2m raised to the power 40k plus 1, where m is an odd natural not ending in 5, not ending in 5. For example, 94 raised to the power 81, it is basically 2 times 47 raised to the power 40 into 2 plus 1. So it is 2m raised to the power 40k plus 1. M is a natural number, odd natural number, basically not ending in 5. It is not 45, it is 47. Okay, so this was the example for a number of the form 2m raised to the power 40k plus 1, where m is an odd natural not ending in 5. And for all the remaining cases, we'll have four different rules. Okay, the we'll have four different rules for all these cases. Okay, so the first case, for number a raised to the power k where a ends in 0, for number raised to the for number a raised to the power k where a ends in 0, like 4 3 1 2 0 raised to the power 55. Okay, so whenever k is greater than 1, whenever k is greater than 1, the last two digits are double zero. Okay, and if k is 1, we already know the from the given number what are the last two digits, so no problem at all. If we are given with the number, if we are given with the number, we already know if power is 1, for example 4 3 2 1 0 raised to the power 1, then we already know that the last two digits are 10. So from the question itself we know the answer. So for k equal to 1 there is no problem, and for k greater than 1, last two digits are 0 0. Okay, for a number a raised to the power k, same thing. If k is 1, we already know the answer, and if k is greater than 1, for k greater than 1, last two digits are 2 5. The last two digits, for example 5 raised to the power 1 is 5, and thereafter we get 25 125 625 3025. Okay, sorry, 3125, extremely sorry, 3125, and thereafter 15625, and so on. So every time there is 2 5 in the end. Okay, so last two digits are 2 5, and if k is 1, then we can obtain the last two digits by just looking at the number. The third case, for a number of the form 2m raised to the power 40k plus 1, this is what we are going to study. 3 and 4 are to be studied carefully. Let me repeat what I have told you. 4 3 5 6 0 raised to the power 11, last two digits will be 0 0. 6430 raised to the power 59, last two digits will still be 0 0. 1120 raised to the power 1, last two digits are 2 0. For all powers greater than 1, last two digits will be 0 0, because this is a case of 0. First case over. 125 raised to the power 633, this is 5, so last two digits are 2 5. 3117395 raised to the power 13423, this is 5, so last two digits are 2 5. 1569335 power 1, it is power 1, so we can obtain by just looking at the number, last two digits are 3 5. So in case of power 1 the situation is different, otherwise every time we have the last two digits as 2 5. Same here in case of 0 at the end. Okay, the third case, for number of the form 2m raised to the power 40k plus 1, 2m raised to the power 40k plus 1, I am telling you 2m raised to the power 40k plus 1. Okay, that means, for example, 94 raised to the power 41, or 94 raised to the power 81, or 94 raised to the power 121, or other numbers in place of 94, just like 98. Okay, 66, 98 raised to the power 401, 66 raised to the power 201. Okay, or 226 raised to the power 241. It is what? It is 2 into 113, that is 2m raised to the power 241, that is 40 into 6, 40 into 6 plus 1, 240 plus 1. Okay, so it is 2m raised to the power 40k plus 1. M is an odd natural number not ending in 5. Okay, M is an odd natural number not ending in 5. So these are the cases. What will happen? The last two digits will be, the last two digits will be the last two digits of the last two digits of 2m plus 50. Means the last two digits of this will be 2m plus 50. That means 226 plus 50, that is 276. So what are the last two digits? 76, 76. Okay, so the last two digits of this expression, are 76. Last two digits are of this expression 94 plus 50, that is 144. So last two digits are 44. Last two digits of this expression for 98 plus 50, 148, so 48. 66 plus 50, that is 116, so last two digits are 16. Okay, so this is how it works. Now all the remaining cases. Okay, uh, let me help you revise what we have learned. At first, 41015 raised to the power 1035. What will be the last two digits? 25, because power is greater than 1 and last digit is 5, so last two digits will be 25. 230 raised to the power 113, last two digits will be 00. Okay, 145 raised to the power 145, last two digits will be 25. 1995 raised to the power 1, last two digits will be 95. 420 raised to the power 41. Doesn't matter, it is 40k plus 1. It is 2 into 210. It is not an odd number, and nor it is ending in 5. So we are not going to apply that rule. In fact, that rule is a bit complicated. We have a direct answer. This number is ending in 0 and this is greater than 1, so the answer is 00. But if we have 246 raised to the power 161, we have to just look at, it is 4 into 40 plus 1, so it is 40k plus 1, and it is 123 into 2, odd natural number not ending in 5. 2 into 123, it is m is an odd natural number not ending in 5, so all conditions are satisfied. Hence 246 plus 50 is equal to 296. Last two digits are 96, so our answer will be 96. Okay, now we will discuss all remaining cases. All remaining cases. Here you have to be careful how I am going. It is very sophisticated method of calculating the last two digits. You have to learn slowly and steadily. You have to be careful. You have to be cautious while doing this. It is very important. We will go with the help of examples. Okay, and before starting that, we can mention an additional rule. An additional rule for all the remaining cases. For all the remaining cases, the last two digits of a raised to the power 40k plus r will be equal to a raised to the power r, last two digits of a raised to the power r. So if we are given with 72 raised to the power 842, and we have to find the last two digits, we have to just do it 72 raised to the power 4 into, sorry, 40 into 21 plus 2, so 40k plus r. Okay, 40k plus r, it is just r, so 72 raised to the power 2. We have to do this only, and last two digits will be our answer, because the last two digits of these two will be the same. Okay, this is an additional rule. Okay, now I am going to show you a few problems. This is an additional rule for our help. Now I am going to show you a problem. Hmm. Now, how to solve this 72 square? We still have to do 72 square. We can use binomial or many other methods. What do we apply? You have to be careful while studying this. Okay, you don't have to make mistakes, or you don't have to gain wrong concepts. You have to be clear with whatever I tell you. Okay, so we'll discuss these few examples. Find the last two digits of 1, 72 raised to the power 842 to 47 raised to the power 900. Okay, 52 raised to the power 873. Okay. These are the examples we'll study. 72 raised to the power 842 is basically 72 raised to the power 40 into 21, that is 840 plus 2. So the last two digits will be same as 72 raised to the power 2. 72 raised to the power 2 can be written as 100 minus 28 square, or 50 plus 22 square. Okay, so as far as squares are concerned, or even powers are concerned, okay, first of all we'll talk about squares only. So 100 plus or minus this, or 50 plus or minus this, for even powers, if we do, then in all these cases 72 square, 28 square, and 22 square, the last two digits of all these will be same. It is 22 square is 484. Okay, 28 square is 784, and 72 square is 5184. Sorry, 5184. So the last two digits of all these three are same. So we can use this trick if we are given with even power. So this was one case, but we have to solve many kinds of questions, and the situations in all questions are different. So we'll learn all the situations. This was one situation, 72 raised to the power 842, and after applying that 40k plus r trick, the remaining r was 2, which was a very small number, and this question was easy for us, so we did it this way. But there must be some good ways to do questions like this. Okay, so uh, we'll discuss those techniques with the next example itself, 47 raised to the power 900. Okay, 47 raised to the power 900 is basically 47 raised to the power 40 into 22 plus 20. So this power is 20 now. 47 raised to the power 20. Okay. 47 is basically 47 is basically 50 minus 3. Okay. So we prepare an even power table here. 47 square is basically 50 minus 3 square. So I told you, in case of even powers, this works. Okay. So 47 square will have the last two digits same as 3 square. 3 square is 9, that means 09. So the last two digits of 47 square will also be 09. We will prepare an even power table. At first, 47 raised to the power 1 is, in case of 47 raised to the power 1, the last two digits are 47 itself. 47 raised to the power 2, the last two digits will be 09. 47 raised to the power 4, square of this 9 square, that is 81. Okay, 81 is 100 minus 19, so 47 raised to the power 8 now is basically square of this. So square of this, that means square of 19, that is 361. So last two digits are 61. 61 is basically 50 plus 11. 61 is basically 50 plus 11. So 47 raised to the power 16 is basically square of this. That means square of 11. So 121. Last two digits are 21. Learn how it works. 100 plus minus r, or 50 plus minus r, or r. Okay. The last two digits of all these three will be same. In fact, let me be more clear. No, it was not like that. If k can be written as, or let me say m, if m can be written as 100 minus l, 100 plus minus l, or 50 plus minus n, then m raised to an even power, l raised to an even power, n raised to an even power, last two digits will be the same. Last two digits, these powers must be same. Okay. If m can be written like this or like this, then m square, l square, n square, all these three will have the same last two digits. Okay. This is the funda. Now let me repeat what I told you in this even power table. This is very important. We'll do more examples of this for the concept to be clear, very clear. We started from here, 47 raised to the power 900. This is very clear, 40k plus r. So it is basically only r. Now we have to go to power 20. For power 20, we have to make a table just less than 20, 1, 2, 4, 8, 16, and then we get 32. 32 is more than 20. So we stop here. Okay. Now 47 raised to the power 1. Very clear that last two digits are the same as written here, so 47 itself. Okay, now 47 square, we have to check the vicinity, the closeness with 50 or 100. It is very close to 50. What is this for 50 minus 3? So we have to square it. We don't square 47, it is a large number, we square 3 simply. 3 square is 9, so 0 9. Okay, now square of 2, no, multiplying this power with 2, square of this is 47 raised to the power 4. So 47 raised to the power 4, that means the for the last two digits we need to square this 0 9. 0 9, the square will be 81, so the last two digits will be 81. Okay, now square of this will be 47 raised to the power 8. That means we need to square this. 81 is more close to 100. 81 is closer to 100. Okay, 81 is closer to 100. We can also write it like this: 50 plus 31 or 100 minus 31. Now we have to square that. So 19 square or 31 square, both will work for us. Last two digits will be the same. 19 square is 361 and 31 square is 961. Anyway, the last two digits are 61. Okay. Thereafter we get 47 raised to the power 16. That means we need to square this. This is close to 50. So 50 plus 11. Okay. That means we need to square 11. 11 square is 121. So last two digits are 21. This is how we prepared the even power table. Even power table. It may look to you as a lengthy process, but as I am explaining it to you for the first time, that's why it is lengthy. When you are acquainted well with this process, then it is very easy and very quick. Okay. There are many ways, but I love this one. Okay, so 47 raised to the power 20 can be written as 47 raised to the power 16 times 47 raised to the power 4. 47 raised to the power 16 times 47 raised to the power 4. So 21 and 81, last two digits will be 21, 81. We need to multiply these. So last two digits are to be multiplied basically to get the last two digits of this original number 47 raised to the power 900. Okay, so after all these time saving processes, after all these techniques, in the end we have to do a bit of calculation. In the end we have to do a bit of calculation. Sometimes we can't avoid that. Okay, we need to be prepared for this. So 21 into 81, it is basically, sorry, 21 into 81 is basically 1701. So last two digits are 01. So last two digits of 47 raised to the power 900 will be 01. Okay. Now we move to 52 raised to the power 873. 52 raised to the power 873. It is basically 52 raised to the power 21 into 40 plus 33. So 40k plus 33. So it will be 52 raised to the power 33 as far as last two digits are concerned. Now we have to prepare the table up to 52 raised to the power 1, 52 raised to the power 2, 4, 8, 16, 32. Okay, 5 2 itself. Now 2, 50 plus 2, so 2 square is 4, 0 4, then 16, 256, so 5 6, 50 plus 6, 6 square is 36. Okay, 36. 36 is 50 minus 14. So 14 square is 196. So 96. Okay. Now for 52 raised to the power 33. For 52 raised to the power 33, we can write it like 52 raised to the power 33 times 52 raised to the power 1. Okay. 52 into 96. 52 into 96. The childhood calculation techniques can be applied here. 50 plus 2 times 100 minus 4, that is 5000 minus 200 plus 200 minus 8. Okay, so that is 4992. The last two digits are 92. The last two digits are 92. So this is what you learnt about last two digits. Let me tell you a few more rules, a few more things about this last two digits topic. A two digit natural number. A two digit natural number. Last two digits of 47 square. Last two digits of 47 square. 47 square is basically 47 square is basically 50 minus 3 square, so 09. Last two digits of 81 square. 81 square is basically 100 minus 19, so 361, that means 61. Last two digits of 61 square. 61 square is basically 50 plus 11, so 11 square is 121, 21. Last two digits of 52 square. 52 square is basically 50 plus 2 square. Okay, so 2 square is 4, that means 04. Last two digits of 56 square, that means 50 plus 6 square. 6 square is 36. Last two digits of 36 square is basically 36 square itself, we know 1296, or we can do 50 minus 14, that is 14 raised to the power 2 is 196. Last two digits are 96. Last two digits of 88 square is basically 100 minus 12, so 12 square is 144, so last two digits are 44. Okay, in case of two digit naturals, we can find the squares or power 4 like this. Okay, so this was the topic, last two digits. Now we have to learn remainders. These are a few questions in front of you from the topic remainders. 7 is completely okay, but 7 raised to the power 25 when it is given, we don't know much about this. And now we have to find the remainder when 6 divides this. This large number is divided by 6 and we have to find the remainder. We don't know this number, so we can't perform actual division, and hence we can't find remainder directly. So there must be a technique. Yes, 7, it is basically 6 plus 1 raised to the power 25. At first we try to find 7 by 6. What is the remainder? When we divide 7 by 6, the remainder is 1. Okay, when we divide 7 by 6, the remainder is 1. If you are using different books or materials of different authors, or so some write like this, 7 mod 6, that is 1. 7 divided by 6, remainder is 1. So 7 raised to the power 25 divided by 6 is basically 1 raised to the power 25 is again 1. So we have our solution ready. Now 7 raised to the power 25 divided by 4. Now what we see is 4 divided by 7. At first we find this. 4 ones are 4. 3 is remaining. 3 is a large number. Uh, if we compare it with 4, it is not just 1. Okay, it is not just 1. It is much larger than 1 as compared to 4. So it is more than half of 4. We can write it like plus 3 or comparing with this, if it was 8, it would completely divide, 4 would completely divide 8. What was the deficiency which caused this remainder to occur? The deficiency was 1. So this 3 remainder can be also written as minus 1. This minus 1 you can find in many books or solutions or authors or portals. The minus 1 in case of a remainder means divisor minus 1. What is the divisor? 4. So 4 minus 1, that is 3. 3 is the actual remainder. So these remainders can also be written like this. For example, 6 dividing 7, 6 dividing 7 was written as, the remainder was written as 1. The remainder was written as 1. We can also write we can also write the remainder to be minus 5. Okay. But in that situation, but in this question, it would not help us, so we didn't use that. In this case, minus 1 is a very small number, and 1 raised to the power anything gives us 1. So it is very convenient for remainders to be as close to 1 as possible. As close to 1 as possible. Remainders to be as close to 1 as possible. That is our main task. That is our main technique. That is our main trick. So we do this step by step now. 7 mod 4 is basically 3 or minus 1. 7 raised to the power 25 mod 4. It is not the modulus. It is mod. That means 7 divided by 4 and giving the remainder this. Okay. It is a way of writing. 7 raised to the power 25 mod 4 is 3 raised to the power 25 or minus 1 raised to the power 25. One more thing, 3 raised to the power 25 will be greater than 4. How can it be remainder? So again divided by 4. It will complicate things. It will complicate things. So this is more convenient. This is more appropriate. Minus 1 raised to the power 25 is again minus 1. What I just told you, the meaning of remainder minus 1 is divisor minus 1. So 4 minus 1, what is the remainder? 3. 3 is the remainder when 7 raised to the power 25 is divided by 4. Okay. So now we move on to C. 3 raised to the power 45 divided by 8. 3 raised to the power 45 divided by 8 is basically 3 is not close to 8. Okay. We can do it. 3 square is 9. Okay. So it is 3 raised to the power 44 plus 1 by 8. 3 raised to the power 2 into 22 into 3 raised to the power 1, because power, there is addition in case of power. So with the law of indices we can write it like this. We can break in multiplication. It is 9 raised to the power 22 divided by 8 times 3 by 8. What will be the remainder? Remainder will be 9 raised to the power 22. Remainder will be 9 raised to the power 22 mod 8 into 3 mod 8. 3 divided by 8 will give the remainder 3 itself. So it is basically 9 raised to the power 22 mod 8 times 3 only. Okay. We have to find this only, and in the end we have to multiply the remainder by 3. And if the number we obtain now is greater than 8, then we have to divide the same again by 8. Okay. That is very important. If for example we get 3 here, and 3 times 3 is 9. So dividing something by 8 can't give the remainder to be 9. So 9 will again be divided by 8. Okay. Whenever it is larger than the divisor itself, it is again divided in this process. That is the main technique. Okay. So now our concern is to find this. 9 mod 8 is 1. 9 raised to the power 22 mod 8 is 1 power 22. That means 1. So what is this? This is 1 into 3. Okay. It is not greater than 8, so we don't have to divide it again by 8. 1 into 3, that is 3. So the remainder, when we divide 3 raised to the power 45 by 8, we get 3. The remainder will be 3. The last one is 14 raised to the power 15 raised to the power 16. Sometimes we have to use our common sense. 14 raised to the power 15 raised to the power 16. 15 raised to the power 16 we have to consider first. Anything it is, it is 15 raised to the power 16. It is odd raised to the power something. Odd raised to the power something. 15 raised to the power 16. It is odd raised to the power something. So this power is odd. 14 raised to an odd power. Okay. 14 raised to an odd power divided by 5. 14 mod 5 is 4 or minus 1. Minus 1 raised to an odd power is again minus 1. So 5 minus 1 is 4. Sorry. 5 minus 1 is 4. Minus 1 means, remainder minus 1 means divisor minus 1. Remainder minus 2 means divisor minus 2. That is a simple rule. Okay. Oh, 1 minute. Okay. 14 raised to the power 16, 15 raised to the power 16 is basically 14 raised to the power odd, and 14 mod 5 is 4. When 14 is divided by 5, we get 4 as remainder. Okay. So 14 mod 5 is 4. That is also minus 1. That is also minus 1. Minus 1 raised to the power odd, because 14 raised to the power odd. So minus 1 raised to the power odd is again minus 1. Minus 1 means 4. Done. So we will continue the topic remainders in our next lecture of number system. Okay, right now I am concluding this video at this point. Thanks for watching this video. If you have any doubt, you can send us on WhatsApp 8294600829. Let me tell you that this number is only for WhatsApp, not for calls, not at all, not even WhatsApp calls, only WhatsApp texts. Okay, this number is for WhatsApp. You can WhatsApp all your doubts here. And thanks for watching this video. Don't forget to like, share or subscribe. That is very important. Happy learning. Bye bye. Thank you so much.